So we had T1 and T2 relaxation times. The T2, that's the time for our protons to resonate and then flip back and release. So we're sending a radio signal, we get the resonance, and then the proton flips back to its processing state and releases. So we have these two times, T1 and T2. In tissues with a lot of water, they tend to be towards the longer time, the T2 time. So they take quite a while for that T2 relaxation to occur. And you can see, we could tell the difference between two different parts of the brain, the white and the grey matter, the heart, the blood, so they all have different levels of water content, and MRIs are very, very sensitive to water content in tissues. Something that we make good use of. So when there's a lot of water content, a lot of hydrogen bound in the water, not bound in the larger carbohydrates, fats, lipids and things. So when we have that longer T2 time, that tends to indicate a lot more water in the tissues. Now because tumours have a lot of rapid cell division, high growth rates, they have a high blood supply, and they have typically a higher percentage of water. So they can be clearly imaged using MRI imaging. And they have that T2 time, that longer T2 time. So the T1 and T2 times indicate whether there's a lot more water, percentage of water content, or shorter times, so T1 is shorter. If there's more carbohydrates or lipids or other things that have hydrogen in them. The difference in T1, T2 times, when you have a lot of water, you have a lot of hydrogen ions, and they tend to, when they start to resonate, when you get that resonance effect, they tend to take a while for them all to relax back into their other state. The ones that are locked up in longer chain carbohydrates and things tend to relax much more quickly, have a lower relaxation time. So hemoglobin molecules can also provide that identifiable resonance. So it can be used to compare blood content of different tissues. And remember, cancerous tissues have more blood supply. The brain can show more contrast than in an X-ray. So these two images are MRI images, and you can see fantastic detail within the brain. Not so much in the bone. So CAT scans might be better for looking at bone because they have a lower water content. But the other tissues fantastically. And they can be tuned to focus on that longer T2 time, or tissues with a lot of water, or the shorter T1 time with tissues such as fats. The brain has quite a lot of fat in it, so very useful for imaging soft tissues of all types, MRI scanning. And it's non-ionizing radiation, so that's very important.